A circle is like a one-sided shape. It does have a few important details that are very descriptive of it, though. A circle is smooth and round shape, localized around a central point called, well, the center. This center is equidistant from every single point, and this distance is called the radius. So every point on the outside of the circle, you can draw a line straight to it, and it's always going to be equal to r. Now, if we draw a line going straight through it, straight through the center, and crossing the other side, this is called the diameter. This is also, the diameter is also equal to twice the radius. Polygons had perimeter and area. The circle does too, but the circle's perimeter is a little bit different. It's called the circumference, and the reason why it's different is because polygons have straight, flat sides. The circle has one smooth side, so it's not found the same way as a polygon is. Now, there's two ways you can find the circumference. The first way is to take a tape measure and actually measure all the way around the circle. What's easier is just to find the radius and use it in a formula. The circumference of the circle is 2 pi times the radius, which is the same thing as, well, twice the radius is the same thing as the diameter. So it's diameter times pi. Either way, it works. Whichever one you want to use depends on the situation, but I tend to always look at the radius just because the radius tends to be the most useful. Now, what's interesting, the way pi came about is that people would measure the circumference of a circle and divide it by the diameter of the circle. Or you could say it's the same thing as the circumference of the circle divided by twice the radius. And pi was always the result, no matter the circle, no matter how big or small it was. Pi is always the result of that. It's a constant. It never changes, and that's how it's defined, the circumference divided by the diameter. Now, the area of a circle, this uses pi in it. The area of a circle equals pi times the radius squared. You have to use the radius for the area. That's why I tend to just look at the radius for the circumference as well. But it's pi times the radius squared. Because the radius is being squared, that's how we get square units, which is an area measurement. But pi is always a constant. You can look up, million places of pi, billion, whatever. But typically we use 3.14. It does continue, and it continues to 5926 and continues on that way. But typically we just use 3.14 as the estimation for pi. Okay, we're going to use these formulas that we've written out. Area equals pi r squared. I'm going to use lowercase r for the radius and lowercase t for the diameter. The circumference equals 2 pi r, which equals pi times diameter. If we have a circle with diameter 48, what is the radius? Well, that's quite simple. The radius is half of the diameter. So if the diameter equals 48, then the radius equals 48 over 2, which is 24 kilometers. A circle with radius 10 miles has what diameter? Well, if the radius equals 10 miles, the diameter equals twice the radius, is 2 times 10, so 20 miles. What is the circumference of a circle if a circle has diameter 19 meters? The circumference is pi times diameter, and we know the diameter is 19 meters. So pi, I'm just going to use 3.14. So 3.14 times 19 is 59.66 meters. Find the circumference of a circle with radius 2.5 feet. The circumference with radius is 2 pi r. 2 pi times the radius, which is 2.5. 2 times pi times 2.5. I'm using 3.14 as pi. A lot of calculators have the pi button, which you should really use that if you can. I'm just using 3.14 to make sure you have the same units as I do. Some calculators have better accuracy with pi, others have less, so it's not going to be the same number, but I'm just using 3.14. So circle with radius 2.5 feet is 15.7 feet. Find the area of a circle with radius 7 millimeters. The radius is 7 millimeters. The area of a circle is pi times the radius squared, which is 7 squared. So 3.14 times 7 squared. 7 squared is 140. It's just 49. So 3.14 times 49 is 153.86. It's going to be in millimeters squared. Find the area of a circle with diameter 18 yards. So we have the diameter equals 18 yards. We do not need the diameter. We do not want the diameter. We want the radius. So we need to find the radius. 18 divided by 2 is 9 yards. So the area of a circle is pi times the radius squared. 9 squared is 81. So we're just going to do 3.14 times 81. That gives me 254.34. This is in yards squared. Now, you would need to do rounding. Obviously, this right here only has 2 significant digits here. So we should round it to this would be 250 with significant digits. But since nothing is stated, I'm just giving you the full answer because typically the problem will state if it needs to be rounded, and you'll use that to guide you. Like for instance, this one right here, this only has 1 significant digit. If I were to round this one to 1 significant digit, then this would be 200 millimeters squared, which is quite an inaccurate measurement. That's the reason why you really should be measuring, to some accuracy, like be 7.00 millimeters. That would be 3 significant digits, and then we would round to 153 millimeters squared. But just use the problem, whatever it tells you to do, that's what you should round with. All right, I've got a couple application problems to do. First off, find the area of this figure here. Now this figure is like a teardrop kind of shape. And we have 2 parts actually. We have a triangle on top and a semicircle, or in other words, a half circle on bottom. The half circle, we have a center with a certain radius. Now that radius is actually the same thing as half of this 12.8 centimeters. We need to know the radius to find the area. So we can actually just take 12.8 and divide it by 2, and that gives us 6.4 centimeters as the radius. Now, the triangle part, you'll see 12.8 centimeters on all sides. That means that this triangle part is actually an equilateral triangle. There is a formula for the area of an equilateral triangle. The reason why we would use the formula in this case is because we do not know the height. We can find the height, but it's going to require a lot more work, which I haven't shown you before. However, we do know the area of an equilateral triangle using a simple formula. It's actually not terribly hard to prove, but I'm not going to do it. I think it's a little too much right now. But how you would prove it is you would just create a line going straight down, and that's your height. That's what you're trying to find. And we're going to use this triangle here, or the other one, we can use that one, and just label all these things X. And you use the Pythagorean theorem to prove it. Like I said, I'm not gonna do it here, but when you do prove it, you find that the area of an equilateral triangle equals root 3 divided by 4 times the base squared, whatever the base might be. In this case, the base is 12.8. So we have two figures. We have the triangle on top, which is equilateral, and we have this semicircle on bottom with a radius of 6.4 centimeters. This one has a base of 12.8 centimeters. So the area of the equilateral triangle, as I gave you the formula for it, root 3 over 4 times the base, in this case 12.8 squared. That gives us the square root of 3 divided by 4. It's going to be 0.433 times 12.8 squared. That gives us 70.9. I'm going to round it 2 decimal places, so 94. This is going to be in centimeters squared since it's an area. Now, this semicircle, which is half of a circle, is also half of the area of the circle. So the area of a circle equals pi times the radius squared. The radius is 6.4 squared. So 3.14 for pi, and then times 6 squared, 6.4 squared. That gives me 128.61. And this is for the full circle, so we need to take half of that. It's just 1/2 the 128.61. That gives me 64.305. So I'm going to write it as 64.31. And then all we have to do to find the area of the full figure is add up these two parts. The 1/2 area of the circle. That gives me 70.94 plus 64.31. Which is 135.25 centimeters squared. This is an interesting problem in that we have a track, which is the blue part here. The track is just on the outside. We're trying to figure out how long must the track be. Oh, sorry, how long must each straightaway be? The question marks here, which they're both going to be the same. It's equal on both sides. How much must the straightaway be so that we can have a grand total of the blue track being 400 meters long? So they gave us this 32 meters. That is the radius of this semicircle, which is going to be the exact same thing as the radius of this semicircle. And we need to know that because the outside circumference of the semicircle is also a part of this 400-meter track. So we need to know what the circumference of the semicircle is. Now, what you can see is you can either calculate the circumference by taking half of the circumference for both of them. But since we have two of them, we're gonna cut off. Let me do it in red here. We're gonna cut off this part, and if we glued them together, you would see that it makes a full circle. And all of that is going to be a part of the track. Like I said before, you could just take half of this, 1/2 of the full circumference of the circle from there, 1/2 of the full circumference from the circle there. But that's the same thing as just taking the full circumference of this circle. And then we have these two side lengths that we don't know. I'm going to name those X. Since we don't know what it is, but we want to know what it is. That's why I'm giving it a variable name. So let's first find the circumference of those outside semicircle parts. The circumference of those semicircles is going to equal pi times the radius, 2 pi r. The radius is 32 meters. So for the entirety of the circle is going to be 2 times pi, 2 times 3.14 times 32. That gives us 200.96 meters. And that's for each part here, right? That's well, if you divide it by 2, so the 200.94 divided by 2 is going to be 100.48. So each one of these semicircles, let me clean this up just a little bit. So this, do it in green, let's do it purple. This purple distance here is 100.48 meters. The same thing is true for this purple distance here. Which is why we don't really need to take 1/2 of both, because together they make the whole circle. Now this X part is what we're looking for. That's the straightaway on both of these sides. And there's 2 of them. So we know there's 2 X's. And if we add to this the side measurements of the 100.48, which is a total of 200.94, this total thing here adds up to 400 meters of track. That's because we're considering the purple parts, which I should actually write this in purple, and the black X parts, which are the straightaways. That's what we're looking for, which is 2X, since there's 2 of them. They have to equal 400. So this is actually a 2-step equation. We just subtract first, giving us 2X equals should be 199.06, and divide by 2. Let's see what that is. 99.53.